At this point, I want to talk about the top 5 causes of foodborne illness in the United States. Currently, they are improper holding time and temperatures, poor personal hygiene, inadequate cooking, contaminated equipment, and food from an unsafe source. The number 1 cause of foodborne illness in the United States is improper holding temperatures. This seems like a pretty simple principle. Keep hot foods hot and cold foods cold. Unfortunately, it's the top cause of foodborne illness. The temperature danger zone is any temperature between 41 and 135 degrees. This is where harmful bacteria rapidly reproduce, especially if the potentially hazardous food has been in this danger zone for more than 4 hours. That's why it's so important to monitor time and temperature during the food preparation process. Within the topic of holding temperatures is how to properly cool foods from hot to cold, reducing the amount of time the food spends in the danger zone. So what are the best ways to cool potentially hazardous food? Once you're ready to cool your food, it's best to use an ice bath, shallow pans, preferably metal, smaller portions, and frequent stirring. This must be done before you put the food into the refrigerator. Potentially hazardous food must be cooled from 135 degrees to 70 degrees within 2 hours. Then cooled from 70 degrees to 41 degrees or lower within the next 4 hours. Putting hot food into refrigeration can raise the temperature of the unit and thereby put other foods at risk. Once the food reaches 70 degrees or lower, you can put the food into shallow or small containers and put into the refrigerator uncovered. The only time a food should be uncovered is when you're cooling foods. Once the food is cooled completely, cover with an approved cover such as a lid, aluminum foil, or plastic wrap. Here are some tips for keeping cold foods cold. Do not overfill the refrigerator. You put a lot of stress on the refrigeration unit when you overfill it. It becomes difficult for air to circulate and the refrigerator is constantly working to keep all the food cold. After receiving a shipment, refrigerate food as soon as possible. This should be a number 1 priority, so make sure there's someone available to inspect deliveries and check temperatures so that the food can be moved into a refrigerator or freezer as quickly as possible. Do not thaw potentially hazardous foods at room temperature. There are 3 acceptable methods of thawing food: under cold running water, in the refrigerator, or as part of the cooking process. Now let's test your understanding of refrigeration and thawing techniques. Myth: refrigeration stops bacterial growth. Fact: refrigeration slows but does not prevent the growth of harmful bacteria. The same goes for freezing and hot holding temperatures. Myth: I can safely thaw food on the counter at room temperature. Fact: food thawing at room temperature allows for the food to remain in the danger zone. Thaw food in the refrigerator, under cold running water, or as part of the cooking process.
Celeste, when you look at this picture of a salad bar, what do you see that's wrong? And let me help you out. It may not be seeing, but what we have here is an infrared thermometer showing a temperature of 54.7 degrees Fahrenheit.
You are exposing the salad bar ingredients to temperatures in the kitchen that is 11 degrees, no, sorry, 14 degrees too high.
And what kind of foods specifically are we talking about?
The dairy products and then a couple of them.
Those are commonly called potentially hazardous foods. They have water activity. They have, if you think about Fat Tom, all the characteristics of a food that can support bacterial growth very quickly in that danger zone. So if we look at a salad bar, the potentially hazardous foods that we see are the butter, the yogurt, the sour cream, or the cottage cheese. We also look at the fact that sliced tomatoes have been now and are now being called potentially hazardous food. But you have some other things up there, and that's egg. So all of those have to be maintained at a temperature of what? 41 degrees or below. Now, something here that we also notice that you may or may not see here is all of these pans are plastic. And plastic pans do not allow for cold to be wrapped around the food because it doesn't conduct cold very well. So the recommendation is that pans be metal if at all possible. Now, what happens with cold? Does cold go up or does cold go down? Real simple. If I'm cooking on the stove, where are my hot vapors going? Up. If I put something under refrigeration, it starts from the bottom because cold goes down. So in our coolers, when we're making cold temperatures, it actually starts from the floor. That's why we have fans to circulate it, just like a convection oven. So if we're putting ice on the bottom of the pan, what are we chilling? Not the food. We're chilling the metal that's part of it. So that's why you have things like cold caps. And what's happening with the majority of salad bars that are not ice controlled is you have circulating cold air, which means there's got to be an air gap between these pans. So ice is ineffective unless it comes to the sides of every pan in a salad bar. Any questions?
Let's open this up. Yes.
Could you use ceramic?
Ceramic is a good conductor of cold. It's a lot better than plastic. So yes, indeed, you can use that. Corning ware, same way.
I know Canberra makes a ice pan now. You can freeze up at a time and put it on salad bar water, and it'll stay cold for 8 hours, stay frozen for 8 hours, and cool temperatures.
Has a cavity in it, and that particular cavity is filled like water, sort of like a thermos around the food. Another idea is that you take something, and it's not a popsicle, but it's basically the same principle, and stick it in the middle of the food. So you have a finger basically going down into the food that's frozen. And you'll see that in beverage containers more than this. So anything that we can do to introduce cold into the food, because cold also goes to the sides and down. Now, if I cover this with something other than saran wrap, I will have a better chance of keeping this area cold between service. You don't want to cover it while you have service because customers can't get to it on the salad bar. But remember, cold has to go up on the sides because total temperatures move down, not up. Any other questions?
You know, one of the elements that I look for in all the managers is that to be out in operations, to be hands-on. You know, we don't look for office managers, maybe we have admins or such for that. And the reason is, during operations is when you catch any breakdowns. And what you see here, taking temperatures, should be done on a regular basis. You're out there and you're checking temperatures. That is the biggest challenge that you have as a manager to fulfill requirements because it's a variable. It's a variable that changes regularly. How you come from the oven, hot, cold, 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 to out to where it's going to be served. We have the proper elements there. So the constant checking of temperatures is key to fulfilling our requirement of food safety.
Bruce, another thing to add to help make it colder is not just ice, but if you add water with the ice in the wells, it flows around that better. It's going to keep it colder. So we always make sure we put not just ice, but water in with the ice so it maintains that also.
Water will help fill in cavities. Ice sometimes falls away, but it will last longer. Now, when we're talking about temperatures and monitoring temperatures, we use the infrared thermometer. We also can use a digital thermometer, whether that be the STEM type or not. But we want to make sure that these are properly calibrated. Now, on this case, I'm looking at surface temperature on the salad bar. The reason is, where is the customer getting their food from? Most of the time it's a surface, or they're stirring that surface into the remainder of the items, which means that all we're doing is helping bacteria grow. So surface temperature is sometimes the better indicator on salad bars when it comes to potentially hazardous food.
Any other questions?
Yeah, I have a question. Like, for instance, I don't know how this would play, but like, if you covered it, say for like a significant amount of time, like the condensation would build up, would that cause any kind of contamination at all?
Certainly, water can grow bacteria. So you've got to make sure that in a refrigerator, that if you put a pan over it, that you don't have the leaking condensation coming down. And if indeed it's a piece of saran wrap and you put it in there, that you don't have the condensation below it. So water can contaminate, yes. That's why you have to have a little bit of airflow to let that heat out. Okay?
Something that we've done is we're not filling our cans completely full, so we're constantly, they're lower, so they're staying colder, but then we're refilling with fresh, cold product when those are empty, so we're constantly keeping temperatures down by minimizing the product that we put out at all time.
One of the important things is the fact that you use the smallest pan possible. And if you have a lot of volume, it's very difficult at times. But in this particular case, we've got smaller pans. Maybe there are pans of all the same size. But when it comes to potentially hazardous pans, use a shallower pan. Use one that's not as deep and change it frequently. That goes back to monitoring the temperatures of those particular foods. Another thing has to do with food selection. Sliced tomatoes are potentially hazardous. What do we use? Change it to your cherry tomatoes. Just don't slice them. Because as soon as you slice them, they become a potentially hazardous food.
Yeah. My question, why would you use a shallower pan? Because heat rises in the bottom of you're going a deeper pan to keep it closer to the cold at the bottom, would you not?
You want a shallower pan because you're going to use it quickly, and you've got that time period, so it's going to empty. Plus you're monitoring. So if you look at cold, okay, if I've got a 2-inch and that cold is around the pan, some sort of circulation, whether it be by air or the pan's by it. That's why you want to use metal. It'll have a better chance of maintaining. Shallower pans.
So what you're suggesting there, Frankie, is that is probably have a deep pan, have less product in the bottom, is probably a good point towards food safety. But it would look kind of funny to have a deep pan and very little product in it. So we have to find the combination of both to reach both goals.
Again, it comes back to that equipment challenge. The equipment can sometimes be old, so it's that constant monitoring and changing out those pans, keeping your temperatures under control. Anything else? Any other questions? Think about simplification. Think about how often things are being used. Because if cottage cheese is not frequently turning on your salad bar, perhaps you offer a small cup of cottage cheese by request from a refrigerated environment, depending on the operation.